Okay, yeah, good to see. Yesterday we had a lecture from Mr. Zain Reddy sir, 1968 mechanical. So it went extremely well, and we had a pretty good participation as well. And I'd like to thank you again for coming down today. So first and foremost, I'd like to, on behalf of the Alumni Association, University College of Engineering, Usman University, we are going on with this initiative called Alumni Talks. As you know, we'll be getting a lot of eminent speakers. So first and foremost, I'd like to invite the President of Alumni Association, Mr. R.V. Ramanan Rao Garu, to come onto the stage. Request President Sir to please accompany Vijaya Ma'am, who is our guest speaker today. Our next speaker, Mr. Kannan, onto the dance. Thank you. So now the moment of thanking them, I would request Mr. President Sir to welcome Ms. Vijaya Ma'am with a bouquet. Thank you, sir. Even Principal, General Secretary Garu, sorry, our President Sir, Mr. R.V. Ramanan Garu, to give an inaugural note for the session.
I am confused, to be very honest with you. I don't know whether I am coming or going. Too many guests, too many people coming in, too many VIPs. Lot of functions, a lot of speaking, lot of lectures. So I thought it was General Secretary was calling, but then I realized that he is calling the President of the Association. Anyway, good evening once again to all of you. Alumni Association, after reviving, we have envisaged and we have planned a lot of programs. And one of the important programs that we have planned is Alumni Talk. Alumni Talk means we thought outstanding alumni of our college should come and address our students along with the faculty members and interact with them so that it will be beneficial to all of us. And then they will also be like role models, because as you know, at one time, they were also sitting on the other side. Today, after some years, with their achievements, they are sitting here. So they are kind of role models. So with this, I introduce you the two important speakers who have done exceedingly well in their own professions, in their education, in all walks of life. I present to you Sundar and Jaya. Thank you.
Good afternoon to the heads of the department, learned academicians, students and my fellow alumni. As our President has just communicated, that is one of the key initiatives that we have taken up, primarily to bridge two things. One is bringing back the alums to the college and connect them. Second is, in the process, there will be a trickle down of knowledge that each one of us have picked up as we moved on. It's very important, critical thought for two reasons. One definitely is, as all of us know, they would definitely inspire each one of us over here sitting in this room, because each one of us have passed out from the same classrooms. So we are all on the same journey. It is just that the alumni are ahead of you in terms of time. So you can look up to them as inspiration, you can look up to them as what choices you have in life, okay, because they're going to come from various backgrounds. And we're talking about doing at least 2 or 3 per month, and they're all going to be folks from different walks of life but have passed out of this college. So for the student, it becomes very paramount to connect with them, to ask the lot of questions. It could be anything under the sun because they belong here. They belong here. It is not very specific that okay, you need to ask only technical questions. It could be anything under the sun. You can connect with them once they go out from here. And each one of us, I'm sure, who's going to come here would love to talk to you guys. Because when we look back and see you guys, we feel, going back 30 years. Even today when I was standing outside over there and ushering students in, some kids were running out from this side, that side, giving a slip. It was fun, we also did that. It's not that we didn't do it, okay. And we were saints. It's just that, okay, it's fun for all of us to come back and connect with you guys and share what we learned. So, my dear children, take the complete juice from if any of us are over here. So, make the best use of it and attend all the alumni talks wherever possible. Because they're doing it for you. They've taken out time from their busy schedules. They might be visiting Hyderabad on personal work and they're taking out this time for you guys. Okay, look at Kanan. He's come all the way from Bangalore only to give you a lecture ahead of time. Okay, there's a reunion of this, a different question, but he would have planned to come tomorrow. But he's taken the time out and come. Same is the case with Vijaya, okay, who's here on a different occasion, but they're taking time out. So please respect the time and sincerely request that. Even yesterday I requested this. If we say the program starts at 3, let's start at 3. Because that's the first learning that I think we all should learn from the alumni. It's very important and critical because wherever we went out in life, it is so. If you are late by even a half a second, it's very clear that you are late. Because when you jump over a well, you miss by an inch or a meter. Where are you? You're inside the well. So 5 minutes or 5 seconds and 1 hour, there is no difference. So I think discipline starts from there. So, and unfortunately or fortunately, most of us have learned it the hard way once we got into our real life situations and corporate. So this is the key thing that each one of you should take the best out of the alums to come in. Second, when we come talk about the institution as a whole and the benefits for the faculty. The alums who passed out from here have done really well in life and they work in different spaces. They carry a lot of knowledge and they're willing to share this knowledge with the institution. And the faculty can make use of this knowledge in terms of collaborations, partnership with them, bringing their organizations here. Yesterday, Professor J. Reddy was here. He is willing to collaborate. He said whatever, you ask anybody who comes to this college, and the first thing he said was, nobody asked me till now, okay, what they want from this college. I come all over India, I go to the IITs, I go to the top institutions, but nobody from my own college have asked me so far. And you are the first guys who have asked. And I am here. What do you want? You want money? You want anything else? I am here to cut a check. He said, we don't want anything from you. Money will come. We want all the knowledge that you have gained. At least a percentage of that knowledge, please share that with college. And he was willing to collaborate. He was willing to, partner with the faculty over here to do research work, get into publications, etc. So this is not for the faculty too. So that's the reason whenever there's an alumni talk happening, one side interact after that, and the other side of the coin, the faculty is going to spend at least 30 minutes with the speaker, okay, separately, wherein understand what they are doing and what is happening in the college and how they can connect in terms of the research work and the collaborations. So these are very, very critical and important talks that as far as we go, as an endeavor that we have said, let's move forward in terms of bringing something to the college and giving back. And every person who passes out from the college definitely would want to give back to their outcome. So I think as an institution, as faculty, as students, I think let's make the best use of the opportunities that are coming. Okay, and I'll hand over the podium back to Dorna over here. Thank you guys, thank you for being here, and thanks.
Yeah, thank you sir. So without further delay, I think probably the topic that you're waiting to hear. So let's get started with the speaker sessions. First of all, I'd like to thank speakers, both speakers. Actually, Vijaya ma'am took the initiative to reach out. She told that she's interested in sharing her knowledge with all of us, and even Kannan sir agreed. So we are glad that they have come from London and Bangalore respectively, to come and deliver the lecture to all of you. So I would request all of you to use this opportunity to interact with them. They're doing great things in life. It's a wonderful experience to the 20 years ahead. Right? So definitely, let's get started. I'll request rest of the guests to please take the. Please take it. So starting off with Mr. Kannan sir, a brief bio for you. Mr. Kannan is a technology leader at Electronic Technology Center. He is responsible for driving technology development in the areas of controls, optics, instrumentation, electrical power systems, power electronics, safety, and electromagnetics. He has been with GE since 2001, holding various leadership positions within the research organization GE Global Research. In 2009, he moved to Niskayuna, New York, as a power systems platform leader. He was responsible for overseeing all smart grid research activities across GE Global Research. Mr. Kannan obtained his PhD in electrical engineering from Tulane University in 1996, which is in the US. Prior to GE, he worked electric power utilities in the US. He is the immediate past chair of IEEE Power and Energy Society in Bangalore as well. So he has a rich experience in smart grids and extensive experience in fast technology. So I'd like to welcome Mr. Kannan sir to take over the stage. Thank you, sir.
Great. Thank you very much, Praveen. Really appreciate your having me here and share experiences in terms of what has happened since I. Probably request Praveen to give me a heads up like 5 minutes before I need to close my talk. So otherwise this is such an interesting topic that I can keep. No problem. All right, great. Thank you very much, Ramon. So with that said, 3 things. One, I'll give a brief introduction about where I work with General Electric and some of the core technologies that we are developing in the electrical space. Then I'll get into the smart grid area, right, and share with you what is smart grid and what are the various technologies that are happening in the world in the smart grid area. And then also share what's going on in India, right? I mean, from a smart grid perspective, what are some of the opportunities and challenges that are associated with it, and just kind of close in on my thoughts on that particular topic. Before I get started, Praveen had requested me to share some experiences, ever since I left this place, like what all went on and how did I manage to where I am today. So I'll just spend a couple of minutes and kind of sharing it. Right? So first in 91 is when we passed out, right, in August, and as many of you might do in the final year, was very crazy about going to the US. So that was probably the biggest thing at the time. How do I get to advanced studies in the US, right? So we all prepared for GRE and TOEFL and all that, and during my colleague and everyone here, we struggled quite a bit, right? And at that time it wasn't very easy, right? We didn't know, we didn't have any internet or anything like that, so we ended up, going to the US Embassy in Chennai, getting the application forms on paper, everything on paper, right? And I still can remember I had once taken the passports of about 15 or 20 of my classmates, right, to Chennai, and just to get the application forms for the US universities and all that. So that was all great experience, I would say. I mean, things have changed significantly, right? But I was very lucky in that I did manage to get an assistantship, a research assistantship in Tulane University in New Orleans. It's one of those universities that people have not heard also before here, right? But it was just I would say a combination of luck and my background here, right? My academic record here that got me there. And once so we all went as a group together, right, to the US, and we all settled on to various schools and universities. And one of the key learnings that I had when I went to the US from here was that here we were, studying and, doing a lot of things, memorizing a lot of stuff, right? I mean, including formula, including, what was there in the textbook, everything was a closed book system at the time. And my first experience was, hey, the first exam that I took, the professor said, hey, this is an open book system, right? So you can do whatever you want, right? And I felt it was very easy, right? I mean, I said, hey, you can just get all the formulas in the book and write it down. And apparently, what I learned from that was one of the most toughest exams that I ever did, right? And I did not do well. And for somebody like me who likes to excel in academics, right, likes to struggle hard and going there and accepting that failure of not doing well was difficult to digest, right? So, and I thought to myself as to why it has happened, and I, spoke with my faculty members and all that. And the great learning for me was, hey, a lot of stuff that I was trying to do in my exams was through memorizing formula and all that, rather than really understanding fundamental concepts, right? And that became the key learning for me, right? I mean, so from then on, it was more like, really understanding the depth of what the equations really mean, right? And getting into, more, I would say, experimental activities, right? To a level where you can validate what you have done, right? So, I don't know if this resonates with many of you here, but I thought I would share that with you. So that was one experience. And from then on, I moved on quite well from an academic perspective. The next thing that I had was when I finished my master's, right? It was in electrical power engineering, right? The same field there, the electrical department here, the same work that I actually do there. There I found that all my classmates, everyone was getting into computer science. That was a hot topic at the time. It was in 1993, when I finished my master's. And so there was a lot of pressure on me, social pressure to say, I should also get into computers, learn something, go to California, find a job. And that was another experience where I spent a good amount of time with my advisor. And for some reason he motivated me. He said, hey, I see you can do a PhD. Frankly, I did not, when I went to the US, I didn't have the thought of, and have the idea of doing a PhD. Right? And when I finished my master's and sat with my advisor, and he motivated me. He said, you should be doing a PhD now. I mean, you can do it, and I'll support you for it. Right? Then it was like I was in two phases, either to get into other areas and computers and move on and get a job and all that, or stick around and finish my PhD. And for some reason, and don't ask me how and why I made the decision, I said I'll stay back and do a PhD. Right? And so that was another about 3.5 years of work. I mean, it was quite rigorous. And what I learned in my PhD was, just execution of work is not enough. What that means is you should always, challenge the status quo. You should always know what is going on in the world in terms of the current research, and think of something new. What's the innovation that you are bringing in the work that you do. So that's what got me through my PhD, and thankfully things went very well. And in '96 I graduated with a PhD there. And throughout my work, I was interacting with a local company, which is the Energy Services. It's an electric power utility company. So a lot of work that I was doing was industrial research, right? So it was primarily for the industry, trying to, really understand the practical problems and apply, what we have learned from academics in those areas. And, thankfully after my PhD, Entergy said, hey, why don't you join us, right? I mean, you already worked through as a student on our area, right? So I said that was a great opportunity, so I went and joined Entergy in '96, right? And at that time, my learning was, it was in academics. It was primarily all, I would say, more just theoretical stuff, right? I mean, you learn the fundamental concepts, but when it comes to practical applications, things are very different, right? For example, if you're talking about a substation, breakers, or you're talking about stability, and I talk about more on my talk today, it was way different, because it was you're kind of challenged at a different scale. And let me give you one example. Right? I mean, when I was at Entergy doing work on powers, again in the power related area, we had a major, not major. I mean, in the US it was probably like a 20-minute blackout. right? 20-minute outage. We don't call it blackout, it's a 20-minute outage. And that was like a big deal for the company, right? So, and we as engineers had to justify to our management as to why it happened, do a post-mortem and figure out, what we can do to make sure it doesn't happen again. Right? It was a lot more pressure that way rather than the theoretical work where some experiment fails in a lab here, you can always get on to something else. But there it was very different. So whatever you deliver in a real world has to be 100% accurate. So that was my learning in terms of paying more attention to details, getting into the fundamentals of how things get used in a real world. But then there was something which was in my back of my head. This was probably in '98. When we were doing all this, I still wanted to figure out what is there in these computers that is making people so crazy. So I joined an undergrad courses in computers. So I learned C, C++, Java, C++, blah, 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 all that stuff over like say 3 years, right? And once I got a feel for what it is, then I got into a state where I really wanted to be in electric power area, just because that was an area of passion for me, right? And I enjoyed solving tough problems. But then the learnings in the computers actually helped me make my job even better, because I could apply many of the work that I did my learning computer courses in those respective areas. And in 2001, I moved back to India. I wanted to go back here, so I joined the GE Research Center. The GE Research Center was just starting at the time, so there was a need to even set up, the fundamental labs and work. And so I set up the electric power research lab there. So working on power electronics, power systems, energy storage related areas and all that. And in 2009, that's when the smart grid became a big deal, right? So our colleagues in the US said, hey, you wanted to come and spend time with us and educate us on what's going on in the smart grid area and really drive technology development in there. So I did that for about 3 years, right? And then came back to India, and now I'm running the electrical technologies group there, which has a broad set of areas, right? Everything related to electric power, machines, electromagnetics, pretty much everything that you see in electrical engineering courses here, like controls, and also optics, part of the lab as well. So a lot of work going on, and it's a very exciting time. I'm enjoying my work, and I do this as part of my role as IEEE engagement as well. So I've been involved in IEEE for a number of years, and last couple of years, 2014 and 15, I had the opportunity to chair the Bangalore chapter of IEEE Power and Energy Society. So I took that as an opportunity to actually connect with the local universities and R&D institutions, primarily to educate what I know and also learn, right, what is happening elsewhere. So it's been a very enriching experience for me so far. And once again, I'm very, very happy to be back right, with you. With that said, let me get started on my talk. I hope I did not bore you too much. Alright, so first is the GE India Technology Center. Let me tell you a little bit about GE, and then we'll get into the smart space. First, I hope you recognize very soon, right? And he said, I find out what the world needs in SOC to manage. Right? This is how it started with the electric bulb back in 1892. Right? And this is the same philosophy that has been followed in GE throughout, and we still continue to right. So the main thing for GE is technology and innovation that can actually change the world. So it's founded in 1892, 300,000 employees worldwide, about $120 billion in annual revenues. Dow Jones Index that was originally listed in 1896. That talks about the stability of the company, and how it's changing with the time, right, in terms of the kind of technology that we develop. GE is organized right now as we have several businesses, right? These are the businesses that make products, right? So if you look into the renewables business, it's primarily on wind, and now with the Alstom acquisition of Alstom, we are into hydro as well. We make locomotives, right? And healthcare is all when you go to hospitals, you see the CT, EMR, and those devices, right? The X-ray and all that. aviation. Every time you fly, it's an aircraft engine. That's only the business that deals with all the power grid related topics. Right? So it's all the power electronics, power systems related area. And G Power is all the gas turbines, steam turbines, and so forth. The Global Research Center is belongs to the corporate. So it's not where I belong. I'm part of the Global Research. It does not belong to a specific business. So we cater to the development of technologies in all the businesses because areas. Right? So and our focus is also on what we can learn from one area, how we can apply it in other domains. The G Digital one that you see there, it's a new one, it's a new business, and this is something that started about, I would say, 3-4 years ago, with G getting into the software domain as well. So as the world is getting more and more into data and analytics and software, G already has a lot of software that all of the businesses actually use. So it's created a new business, and that's headquartered in California, in San Ramon, right? That primarily drives a lot of software platforms that can be used by not only G businesses but also external. G has been quite active in India, especially in the recent past. Just from a historical, like the 1902 is the first hydro project in Karnataka. This was at 25 hertz level. That was a G system there. And then the last few years there has been like tremendous development in various technologies or innovations related to be it in renewables or healthcare and so forth. Today in India, we've got about 21,000 employees, branches at all locations, our major cities. There are like 4 technology centers, or we call it as engineering centers. Not all of them have research. The Bangalore center has the research, but we have other centers. We have one in Hyderabad as well that does a lot of technical work in the area of energy connections related area. And with our partnership for JV with Alstom, Alstom T&D, right now it's part of GE, right? So that has expanded the scope of what GE is doing in India. The goal for the research, global research, is primarily that to develop technologies for the business. It's first US industrial lab and about 2,500 scientists and engineers, and it's all practical applied research. The centers for the global research are across the world. Right? Main headquarters is in Niskayuna or Albany, New York, and then the second one was in Bangalore that got started in 2001. Then we have one in Europe, in Munich, Germany, and in China. And there's one that's come up like 3 years ago in Brazil. And the Global Software Center, which is called San Ramon, is now LG. So it's pretty much wide across the globe. So a lot of work that we do is pretty global, and it's all virtual teams. So that means we have projects where we have people from across the world contributing. In the technology center here, we have about 5,300 people, so primarily all technical people, and primarily doing masters and PhD. So the research center, there are different groups, just like how we have it in the department. We have different, groups there too. So a lot of technology development that we do caters to, like for example, if I need some help in mechanical or in, if I need some help in software related area, I can find people across who can group together. So there's a lot of focus on cross-disciplinary research, right? So it's not just one specific area that really makes things work. So in the electrical technologies area, which is the area which I drive here in GE, just a brief overview on some of the key technologies. First is we do a lot of work on sensing and instrumentation. So just to give you a feel from a practical perspective, many of the transformers that you have in the world are quite old, right? And they are susceptible to failures. And one of the index that people use is the gases that are dissolved in transformer oil. And so we develop technologies to extract or analyze the gases that are dissolved in there through optics, right? That means through a light signal, and then figuring out, based on signatures, you kind of see, what's, the nature of the, failures that you may have in a transformer. The same thing in downhole instrumentation, that is in oil and gas applications. When you go downhole, right, you want to know how much of what's coming out is oil, water, and gas. So we develop optical sensors for those applications. Emissions measurement, as you know, emissions is the key driver today, right, across. So again, the optical sensing technology that we have developed for other applications, we are now using it for emissions measurement. So we put a sensor at the exhaust of the gas turbine and send light through the exhaust and receive the light at the other end. And really, based on the signatures that you see in the light, you determine the kind of gases that are going on inside the exhaust. And based on that, you decide, whether it's too much of NOx and SOx and all that's coming out, or you're okay with it. One of the recent technologies that we have developed, this is on wireless power transfer. Right? This is one of the cool technologies where through inductive charging, you can actually charge an electric vehicle up to 3 kilowatts or even like 10 kilowatts. Right? So if you want to charge an electric vehicle today, just go ahead and plug your cord. Right? So instead of that, what if you have something underground, right? And then you just come and park the car, right? And the battery that you have inside the car, right, gets charged wirelessly. So this we demonstrated with Mahindra, right, with their, I think, the Reva and the E2 vehicles there. We're still waiting for the market to open up a big way, but just from a technology perspective, we are ready for something. A lot of work on grid-related space, and I'll talk more on the smart grid aspects. And then on renewables and engine-related controls. So those are, I would say, the big areas that we work on in the organization. And all this is in Bangalore. Now I'll come to the core topic. This is on smart grid, right, and what it is and what we are doing. So if you really look at how things have changed over the years, right, in terms of the grid itself, traditionally you would see that the power is generated at one place, it gets transmitted at high voltage transmission lines. These are 138 kV and above, right? And then they get distributed, right? And these are like 11 kV, 13.8 kV, and so forth. And then you have loads like residential, commercial, industrial loads. So it's been a one-way type situation. And what's happening is, especially if you look at countries like US, right, where the grid has been there for such a long time, it's quite old, right? There, the grid is actually getting closer and closer to its thermal levels, right? And now with the addition of renewables, right, especially with a lot of wind power coming in and solar power coming in, it is adding a lot of intermittency to the grid, right? So that is creating the grid to be a lot more, I would say, potentially unstable, right? Getting the system more closer to its stability limits, right? And that's a major cause for concern, right? If you don't do anything today, you might have challenges with more, issues with blackouts and other things in the future, right? So that's one way things are changing. And if you look at, how things are changing in the future and where things are headed, you are getting into more distributed generation, right? That means people are going to have solar at the rooftops, and you're going to have power flowing in, in the other way, right? Rather than just coming to the loads, it's going the other direction. Energy storage is coming as a big way, right? With lots of battery technology coming up, right? And smart meters and smart homes, where sitting in a control center, can you know exactly how much power is consumed by who and things like that. So a lot of I would say technology development opportunities that are in there because the grid is getting more and more complex with the addition of all these uncertain areas. And if you look at the challenges per se, on the generation side, it's primarily on renewables, right? Primarily renewable variability. How are you going to manage the grid from a renewables perspective? So that's one on the generation side. On the transmission side, how do you prevent any kind of blackouts, right? And that's the main focus in transmission when we talk about. And how do you prevent any, with optimal investment in the grid, right? How do you maintain the stability of the land? When it comes to distribution, it's all about power quality and efficiency. Approximately about 10% is losses in the distribution. These are technical losses, right? Not considering the theft or filtration. And with all the our electronic devices coming in, right? How does it impact the harmonics in the system? Right? So those are the big areas on the distribution system that the industry is trying to work on. And then the electric vehicles, that if that comes up, right, to in a much bigger way, we have to be prepared, right? For example, as a utility industry, if we have like 4 or 5 people charging the, at the same time, right, there's going to be an inrush load from the grid, and you can have issues with respect to transformers getting, blown out and something like that. So you'll have to prepare. So that comes to this concept of smart grid. So when this whole thing smart grid definition started, right, it was like, hey, it's just a concept. If you ask any utility engineer, you would say grid is already smart. I mean, it's not like you don't have anything. It's just that there's been so much development in the communication and software technologies over the years that now you can make better use of those to make the grid better. The one challenge in the electrical infrastructure is that it's one of the most complex networks that man has ever built. Why you say that is, let's say Edison were to come today and really look at the grid, right? You'll probably recognize it, like you see the transformers, you see the breakers, and you know exactly what's going on, right? Generators and all that, because that's all that is started, right? You might still question why is it AC and not DC, but that's a different story. But then, if you bring Graham Bell and you show him an iPhone, you probably may not know what it is. Right? So things have changed tremendously in some fields, and things are very complex. And it doesn't mean that people have not worked on it. It's just that it's a very complex subject. Right? So that's why it's kind of how you can leverage the information infrastructure to make the grid better is something which is very critical, and that's what is called as smart grid. The smart grid is just a concept, right? It's not like, hey, I do something and now I have a smart grid. So that's where, yes. Now get your feel for what are the key technologies and opportunities that we have in each of the areas, right? I mean, generation, transmission, and so renewables integration. Right? A lot of focus over the recent past has been on wind, right? And if you look at the wind story, right? The cost of electricity has decreased significantly, especially in the last 7 years. And there's a lot of tremendous growth. Right? Just in the world, we have about 430 gigawatts, 430,000 megawatts of wind capacity, right? And then every year, right, we are having almost like 60 to 70,000 of wind that's getting added into the grid worldwide. And I'll get to the India story. Now, from a technology development perspective, what we are looking at is, say, if you have this intermittency, there are things like voltage regulation that you hope you do, right, in a grid, active power controls, right, and wind energy. These are some of the key technologies that we are developing, primarily to make sure that wind also, tries to behave like a conventional generator. You're not going to get the same power out because that depends on how much wind is blowing. But in terms of leveraging the inertia of the wind rotor to support the grid, right, in terms of providing frequency regulation, or even active power controls. That means if you have a chance to vary, right, the wind. Let's say the frequency is very high, cut down the wind, right? Can you do that fast enough? Right? And voltage regulation. Especially since you have a lot of power electronics that's built within a wind turbine, right? Most of the wind turbines are doubly-fed induction machines. That's what we use, right? And so you can use the power electronics to actively regulate the voltage at the point of impact. The new concepts that are coming up right now is integrated energy storage. These are wind hybrid systems. I have a couple of charts that you know what that is, and also a combination of wind and solar. How that works. There's wind farm control, especially with a lot of analytics development. Can you do better forecasting of wind, and also coordinate the wind farm controls? Right. That is, if you have a wind farm, can you have the first turbine that is in front of the wind farm? Right. Today, what happens is that takes the maximum wind and does not let the other wind turbines produce as much, right? Because of the wake effects that you have on it. So can you ensure that as a team of wind turbines, can you get more power out of the wind farm? just through controls, without any additional, complexity in hardware industry. Those are some new concepts that are getting, developed and implemented. A couple of things on the wind stuff which I have used is on integrated energy storage. So one of the thoughts was, can you integrate a battery within a wind turbine? Like as I said, every wind turbine will have a DC link, right? Because you have a power electronics built in there, right? So can you connect the battery to the DC link of the wind turbine, like integrate it within it? So that means you have a wind turbine, the top is the generator, and the bottom of the tower is your power electronics. Can you put a battery right there and integrate it as one? So every wind turbine has an energy storage device. Now what it does is, anytime you have variation of wind, right, and the grid cannot absorb, you can actually store the power in the battery. And whenever the grid needs it, you can actually send it back. And the reason why this is important is because the utilities are asking the developers, right, to forecast accurately 15 minutes ahead of time how much power is going to come out of the wind farm. Okay? And if they are providing power with a certain error, right, and if the error is increased more than a certain limit, then they are penalized. The developers are penalized, and this happens in the US. Right? And now some of these regulations are coming in India as well. Right? So then this can be like a fantastic story. So besides doing accurate forecasting, you can have an energy storage in there that basically not covers the entire power output of a wind farm, wind turbine or wind farm. But basically you have this as balancing between the forecasted value and the actual value of the wind farm. So you don't need so much of energy storage. So just to give you a feel, a wind turbine that we have is probably around 1.7 to 2 megawatts each turbine. Right? So your energy storage that we're talking about is about 250 kilowatt for 15 seconds, right? 15 minutes. Right? So this was implemented in the US. We developed this technology in Bangalore, and we've taken this in a real plant there. And now we are looking at potential opportunities in India where we can actually implement something. The other one that we have is the wind solar cycle. And this is basically where, I'll talk a little more on the solar side later, but the solar costs have come down significantly. So if you can integrate a solar with wind, similar to what I mentioned before, because the output of solar is also a DC. Right? So can you connect the DC to the DC link of a wind turbine and have an integrated solution, where during the day you have more solar, sun, and in the evenings you have wind. So they complement each other from their energy production, while you're optimizing the total investment that is needed for an integrated farm. Moreover, many of the folks who have developed wind farms now have a lot of open space, right? So that's a good opportunity where they can put solar as well as a part of the solar. So this is a program that we have developed for a company in India, in Anandapur, with Atria, where we are just experimenting as we speak. The wind solar hybrid system, integrated hybrid system is running. So there's always this question of why integrated? Why don't you have a separate wind and separate solar? And the answer for that is just the overall investment. So if you have a separate solar farm next to a wind farm, for example, right, you would need a separate power electronics, you would need separate controls, but you can leverage all of that that's already there in the farm. So that's why that becomes very, very important in terms of how much cost reduction that we can have. Plus, technically we can potentially offer better reliability. Now coming to the solar side of it, a lot of technology development going on there as well, right? And there's potential for huge growth in solar over the years. China is now leading the pack, right? Japan, US, Germany, all big players there. India is growing quite fast, and we're talking about India is slowly moving. But there's a lot of opportunity there for solar as well. So some of the key technology development opportunities as you want to explore in this particular space is, one is definitely the modules. Right? The module costs have come down significantly. There's a lot of room for improvement in efficiency. Right? So there are different types of modules, polycrystalline silicon, monocrystalline silicon, all that. What we are doing in GE is more focused on the thin film. It's a different type of material and the way you develop this. It's cadmium telluride, that's what CDT means. In GE we don't make modules, but we develop the technology that a module manufacturer uses and develops a module. So that's kind of how our engagement has been. Incidentally, the Cantel thin film is something which is upcoming right now, which can offer on-par efficiency with polycrystalline silicon, and offers, takes lesser space, per area. And so this is something that can, potentially be come up more. The next is on the inverters and grid integrating. As I said, the solar output is DC, so you need to convert that into an AC connector. Right? So you need a converter. There are some of the technologies primarily on silicon carbide, and we do have a chart on that where we want it done. And then all the controls that are associated with grid integration. Right? So this is all that is technologies that are getting developed to make sure that the voltages that we have in a grid are regulated with this converter. Solar hybrids, again I'll talk a little more on that. That's besides wind solar, there is a solar diesel hybrid that can play a big role, especially in microgrids and other things. Here, inverter technology with silicon carbide. Silicon carbide is I don't know how many of you have heard of it. It's a new power electronic device. Like how you have this diode, thyristor, IGBT, IGCT. It's like you have silicon carbide IGBT. The advantage of this particular one is it occupies very lesser space, and you can get more energy capture. Run it at higher frequency, you can switch it at higher frequency. So from a system perspective, there's a good opportunity for reduction in the overall footprint, quite significant. Right? And there's more opportunity for technology development in here as well. So in GE, we have a consortium in the US with New York government to actually develop this device further and implement that or apply that to solar inverters and wind inverters, wind converters, and so forth. So primarily to get more efficiency. The other technology in solar that is again coming up is solar diesel hybrid. And you may ask what's new in this? You have solar, you have diesel, you can it's not like a big deal. But the biggest challenge that we are trying to address is that many of the solar diesel systems that we have, the diesel is very inefficient at lower loads, right? And so even if somebody buys a diesel engine, right, diesel generator, and they don't allow it to operate it below 30%. So this one, what we did was we said, hey, can we make? We're using variable speed generator for wind. Why don't we apply that in this type of system? So diesel engine connected with a variable speed generator, and then you connect your PV to the DC link, so you have like an integrated system, not like a separated system. And the advantage that we can get from this one is more like reduction in any diesel savings. And it's when you get into the circuitry of this, it becomes quite intricate, right, in terms of building this whole system and developing the controls to be able to make that happen. But this is a new concept that is coming up right now, right? And we are trying to apply this in India with companies like Tata Power and other utility companies, right? Especially in opportunities where there is microgrid area. The transmission side, this biggest challenge. Now we finished the generation side. On the renewables, uncertainty is a big challenge, and some of the technologies that I mentioned, that we are developing for others. Transmission side, there's large-scale blackouts that are occurring. I think many of you would be aware of the July 30, 31, 2012 India blackout, and all that happens in like few seconds. Sometimes the event will just trigger and the system can fall apart. So how do you stabilize the grid? Right? How do you operationalize? And that's where this concept for wide area measurement systems comes in. When you talk about wide area measurement systems, the whole concept is how can you get information on the grid, right, sitting in the control center or wherever, on what is happening. Can you predict before the grid collapses that something is happening to the grid, so I need to go and take some preventive actions. And so that's basically gaining situational awareness. And they use these devices called PMUs. PMUs means laser measurement units, which many of you not have heard of, but that's something that you can do. And these are like devices that you put in substations, and these capture voltage and current samples at 120 samples a second. Today's system, in SCADA systems that utilities use, they get one sample in 2 to 4 seconds. So this gives very high fidelity data, and now you are able to gather all this data, try to analyze and try to figure out what's happening. So in terms of the architecture, this is all upcoming. This is not like established right now. It's all like evolving. So you've got all these PMUs right here, right? And you connect all these PMUs to what is called as there's a data concentrator. Collect all the voltage and current samples from across the network. And then this is your energy management system, right? And the analytics is where the technology development is. Right? So then you're able to say, that okay, this is how far the grid is away from collapse, and here are the actions I need to take to prevent the grid. So some of the concepts that we are working on is on voltage stability, and some of these you will probably learn in your either final year or grad course. Right? Real-time monitoring of voltage profile and stability margin calculation, so that you identify what are the weak spots in the network, and then you can try to figure out what are something that you can do to prevent such plan. So one is on voltage stability. That's primarily your generator uses synchronism, results in transient instability. So both of these, are pretty important for a transmission grid. On the distribution side, right, the core technologies that we've been working on is on automation. If let's say a consumer loses power, right, how fast can you restore power to customers? Right? Today it takes a lot of time by the time consumer calls the utility sends a personnel, kind of take a look at where the fault is, separate the fault, isolate the fault, and then restore the power. Now, if you have systems in place, you have sensors and let's say in some of the reclosers, that you have in transmission towers or poles, right? And they all communicate with each other across. Right? Imagine a scenario where there is a fault somewhere, and the system itself identifies where the fault is, isolates that fault, and immediately restores power back. So you are talking about from taking 3 or 4 hours to restore the power to 3 or 4 seconds. So it's a big area for research. Fault location identification is another one. This is something which you heard from Tata Power. There are several underground cables, right? And usually they want to detect where the fault is, and in the process they use certain technologies to inject a signal and then really seeing what's happening. Signal to really figure out where the fault is. But then the challenge that they have is they don't know the topology of the cables. So they don't know where to dig. They know that electrically it is so far away, but how do they know, geographically where? So that is another area and then all the stuff that's related to demand response. Right? And this comes into picture where today you kind of plan your grid based on peak load. Right? And you have certain generation there, and you say, how do I optimize it to the generation we need? But imagine, a scenario where you have control over load also. Right? So now you have your set of equations, right, that will govern the network, where you can also optimize load. Right? Load is the negative generator, or generator is the negative. So can you optimize that to a level where you can at any point of time the utility needs let's say 100 megawatts or 200 megawatts. Right? Consumers can sign up for it, saying that hey, you don't have to generate extra power. You can just cut down my power and basically get paid for it, or there's some revenue associated. Right? So those are new concepts that are coming up in the demand response. But for that you need smart meters, you need appropriate communication infrastructure to be able to get all this information to the get 10 minutes, I'll just talk about the India stuff and then those can be applied in any grid because power flow equation, the power flow equation. Now let's look at India, right? And see where we stand from one of the things. Today, India's total generation is about 300,000 megawatts. Right? That's the installed capacity. And we have 5 regions: northern, southern, eastern, western, and northeastern. A lot of those 300,000 megawatts comes from coal. We do have significant renewables. So about 27,000 megawatts of power comes from wind, right, today, and about 7,000 megawatts comes from solar. So this is as of today. It's evolving, right, in India. As you know, we want to get to 175,000 gigawatts of, 175 gigawatts, come to like 100,000 megawatts, and we are talking about wind from like 20,000 megawatts to almost like 35,000 megawatts in the next 2 years. This can really, change the grid, the way you see the grid significantly with this. On the transmission side, right, the grid, the way things have evolved in India is, we have the 5 regional grids. We used to have it when I was studying here, and then north and east got synchronized, and then west, east, and they got synchronized. And it was like in 2014 that the entire grid got synchronized. Until then, they were all connected to HVDC. So what happened in 2012 blackout? Because where the southern region escaped because they were not connected to the main grid. Like we just had. But what happened was you have this northern region where there was a lot of load, right? And you have the western region that was supplying power to the northern. But some of the transmission lines here, they were either on maintenance, right, or there was an issue with the loading, and so one of the relays, thought it was a fault. It was actually a overload, that tripped. So once that got tripped, then the whole load shifted into the other line, and then that got tripped, right? So, and then all the power was going through this from here to here, all the power was going from here to here. Then the two grids started spinning. Right? There was a big, stability, and you can see that. You can see the difference in the frequency when I start. And that caused one small event created a major damage. And I said the only reason why southern was spared is because all the connections to the rest of the grid was through DC grids. So the oscillations that we had in this grid did not circulate to the southern region. So if it was all interconnected, the advantage is you can share a lot of power, right? But the disadvantage is one will have impact on the other one. So we had these phase of measurement units. I mentioned to you about this technology. So we installed it we installed it at a couple of substations like 2 months before the blackout, right? So we ended up, getting the data from the phase of measurement. And here you see that the moment the line tripped, we had like 10 seconds, max, or 8 seconds. We could have taken some action and have prevented. You can see the frequency spread. So, in terms of technology and research, right? If we can develop anything that can, do something in this area, just with all the analytics or with the data that's coming out from the it can make a big difference too. So there's a big plan by our power grid. This is called as what DSM, where the country wants to install like I think 1,600 or 1,700 units across. Right? I think that's well underway. The biggest challenge is what do you do with the data. Right? So IIT Bombay is working on there are a lot of analytics, right? On how do you assess the stability of the grid using Now, the distribution side of it, you probably know a lot of people without electricity here in India. Yes, please.
Sorry for the minimum stress rate for your lecture. I have some work to do on my home. Can I?
Yes. So the other challenge that you have is the power pilferage. right? There's a lot of let's say 15-20% power losses system there, right? So what can we do to prevent all these losses using all the smart grid technology? So those are some of the big challenges that we have. So Government of India, we have initiatives on how to take the smart grid development right from weak planning. And in our country there is 14 pilots now, few years. A lot of money that is spent in there to actually demonstrate some of these pilots in smart grid. And these are all like well underway from our corporate areas. Now let me talk a little bit about the rural scenario and tell you what are some opportunities. So in India we have about 700 million people, rural population, right? And a lot of them have no access to electricity. There are about 100,000 villages which are unelectrified and about 25,000 which are mobile. So now people are looking at microgrids as a big area. Right? Some of the examples that we have over the years, different companies, either so if we are really determined on getting those people, is there something that you can develop a solution which is highly reliable, right? Where you don't have so much of operation maintenance related thing, and you can remotely control from a control center site. So those are some of the technologies or concepts or even business models, right? New business models that has to evolve. When we talk about smart grid, one is it doesn't have to only with demand response or only with transmission, it spans the entire power system. Did cover a couple of topics, especially on cyber security and big data, right? How to deal with data and how to optimize the planning. So those are big important stuff. Controls will be very important as we go on, right? Especially real-time controls. It's a big topic. So primarily it's just next generation, right? There's nothing like we have just one specific area and just focus on that, but systems level understanding of what is happening is very important. Cross-disciplinary becomes very important, right? Because it doesn't, only if you are thinking only from the electrical side of things and not involve the communication or software or then you get kind of glued into one specific area which may not work right. Okay, for example, we know FPMU data you can use to analyze the system and figure out how far this is going to collapse. But how are you going to transmit all the data? Do you have enough bandwidth? So you need to look at that from a complete system. So there are a lot of standards that are coming up, from an interoperability perspective across the various fields. And the value proposition is very important, right? As we get into mode of smart grid, right? Bottom line is everyone will look at how much investment I'm making versus the kind of returns that I'm getting with the kind of technology. So when we develop this, economics become important, payback period, and the entire say business structure of how things will work, where all the stakeholders can make can make profit out of it. So bottom line, I would say this is the best time for folks in electrical power, those who want to be in electrical power, get a broad knowledge, and I think we will probably be much better off than where we are. So I do hope a few years down the road, while we are there to push for, I'm hoping that you all step up too, right, to contribute to the opportunities and challenges that we have, especially in our country. So with that said, I would like to close the talk and be happy to answer any questions. Thank you. Yeah, so today, we have developed a 1 megawatt silicon for solar applications.
So for that is low level.
Low. Yeah, we have not gotten into HVDC type.
No, that's what I am going to ask about it.
Voltage source IGBTs.
So IGBTs are there. So
The silicon IGBT.
Lower level silicon carbide.
Correct. I mean, most of the applications has been in areas where you have space as a main constraint. So you have aircraft power systems where they have used that significantly, and now we are getting into other areas such as solar and wind and other.
One general question: why we are not moving into microgrids?
Yeah.
Still we are in mega grids.
Yeah.
That is causing a lot of reliability problems.
Correct.
And why we should not move to this so-called microgrid?
No, there's no reason why we should not. It's just a question of how do you make the microgrid, work from a remote place, right? So, for example, who is going to own it? Who is going to maintain it? It's not technically I think the challenges can be resolved. Right?
That solves the problem of blackout.
That can solve the problem of blackout. That can solve the problem of providing electricity to so many in the rural areas as well. 100%.
Can you elaborate one point?
Sure.
You mentioned 10 seconds time just before blackout.
Yeah.
What is that?
Okay, so that is the time taken for from the time the fault occurred to the time that the grids started swinging, right, where the frequencies got it separated.
We are not able to identify that problem within the 10 seconds?
No, it's like we are doing a postmortem and able to say that this is what is happening. But in a real system, within 10 seconds, by the time somebody calls somebody and says, hey, there's a fault in the system, 10 seconds is over, right? So can you have like these type of automated systems? Yeah, that's where it's not. Perfect. Okay, you are. Yeah.
Apart from intermittent.
Yeah. Sure. Yeah, sure, definitely. See, one of the biggest challenges is how much of penetration is acceptable, right? And so we did a study in the US system, in the Northeast as well as in California. What we found was up to 30% of wind penetration. This is a study, right? So we looked at the grid, we modeled the grid to go ahead and increase your penetration by 30% and have some kind of a wind profile that keeps changing, over time. And we modeled the system from a dynamics perspective as well as steady state to really figure out at what point of time the grid can, become unstable. And the answer we came up with was around 30% at the time. Beyond 30%, the system was getting weaker and weaker. But that is a case-to-case basis, because if the grid is quite strong, then it can accommodate more wind. But if the grid is weak, then you might have challenges associated with increased penetration. Bottom line is, if you have enough generation that can act fast enough, right, to balance the variation that you have in wind, right? If you have many gas turbine plants, they act fast enough, so you can, have a better answer there. But if the grid has a lot of coal, for example, right, coal will take a long time. So then the grid becomes, weaker, and we have to figure out how to manage. Yes.
Solar, hydrogen, what are the disadvantages?
In Canada, in a microgrid type scenario, the main challenges there were the cost, right, and the safety aspects associated with hydrogen. Technically, it is feasible, right? You can have a fuel cell, with a solar and maybe a battery together combined. But the economics is always, something which it's still being worked on. It's not there where we can say, we can go ahead.
In one of the slides you have shown there is solar hydrogen in India.
Solar hydrogen or solar hybrid?
So there is hydrogen.
Okay, what I was showing in India was more on not solar hydrogen. In case this was maybe a thing. In India, we're talking about more on the microgrids type thing, right? Where you want to have these, standard systems that we can go ahead and put in multiple places, right? There we're looking at solar diesel combination, right? So just by looking at how you can maximize the solar usage, right, while giving 100% electricity to the load.
So the solar diesel, this generation is on demand side, on
Is
the
what?
consumer side.
Correct.
On the consumer
Correct.
side. So this forms the microgrid.
Correct.
So what is the problem associated with integrating this with the main grid?
I would not say there's any problem associated with it. It's just that, this is ideal for scenarios where, for example, if you're looking at so many telecom towers, right, they're all in so many areas across India, right, where the access to grid is not that easy. Right? If the grid is there and it's carrying power, then there's no issues there. So if you connect it to the grid, you can. I don't see any disadvantages there.
Can you specifically explain the role of smart meters in
Yeah.
the smart grid for the system reliable operation?
Sure.
What the features should be for the smart meter?
Sure, not a problem. So when you talk about a
smart meter, right, all it's doing is collecting the energy data, and you can also include voltage and current, and transmit the data to the utility control center, right? Once the utility control center has this data, which they don't have today, right, then they can use the data to figure out multiple things. Hey, is there a pilferage that's going on? Has somebody not paid the bill, for example, right? And if somebody has not paid a bill, can you disconnect it remotely? That means this device can have a switch that you can disconnect from the bus. Those are the main advantages of smart meters. And by doing it, you can actually improve on the economics of the overall. That's where the smart meters come in.
Krishna here suggested solar and diesel.
Yeah, that's one of.
We know that solar is available only daytime.
Correct.
So again, we are using that diesel generator for 12 hours. Correct. Diesel generator is a pollution gas.
Correct.
So why can't we use the PV and battery?
No, it's a question of, yeah,
Why we are going for diesel generator?
Yeah.
12 hours we are running.
Correct. So it's a question of economics. So if people want to use battery, today there are several batteries. I mean, today of course they use lead acid batteries. Right? There are other battery technologies too that are coming up. So technically you can use both solar and with energy storage. And if pollution is your main criteria, then keep this aside and use the battery.
Yeah, one of the now issue is global one.
Correct. But cost is also important. At what economics. And a lot of people, what they are doing is, especially in want to have like 24/7 electricity, right? Then you are ready to pay for it. Then you look at a combination. You have your energy storage and diesel. Diesel is like a backup. Diesel is not the prime source. But in the night, when you don't have anything else and you need the power, then diesel is the source. Or you put a wind turbine. If economics is not critical, then we see the wind. That's also wind, solar
combination, because both are, we can say, complementary.
Absolutely. That's one of the things which I have mentioned.
I'd like to.
Oh yes.
2001 strategy basically because of Maharashtra third zone region. For load management, mass generation. But if it is overloading, how can we bring out new technology so that we can detect it as overload and automatically trip the 33 kV filters? Because they have not tripped the 33 kV filters, and so we call them.
So zone 3 is a trip because of an overload. But if a fault were occurring on that line, one fault could have created a black, right? And that's what you are trying to prevent using all the PMU relays. If it's just an overload type thing that you're looking at, then you have to relook at your relay settings, right? I mean, you relook at that settings to make sure that that this is not a fault and this is an overload. So you have to look at it from a system perspective. And then the second thing that you should also look at is, can we island systems, right? So if it's an overload, you have some time to play around, right? So can you island those systems? For example, if Delhi were islanded at the moment things have occurred. Those are some new technologies that can be addressed. Okay.
So in the interest of time, again, I hate to stop, but after this 2 speaker sessions to personally interact with both the speakers and get to know a lot of people. So it was a very interactive session. Get started, some of these things are out there because these are the emerging technologies and a lot of things are being worked on. So I'll request sir, even at a later stage, if you can be available for the students on a hangout or some other way. So whoever is interested, you can reach out to the Alumni Association. We can set up a time with Kannan sir and we can definitely interact and learn more about it. Okay, so thank you so much sir.
Thank you.
Yeah, please have
Sure.
Recognition. It can recognize is basically trying to mimic human intelligence. We are currently at the stage of what we call ANI, artificial narrow intelligence. That means we are able to simulate human intelligence in a narrowly defined intelligence, which is going to be the next phase of development for artificial intelligence. We are not there yet. And after that, the the projected development in AI is going to be ASI, Artificial Superintelligence. And it's anybody's guess. We don't know whether it is going to be a Terminator kind of a scenario. Okay, or it's going to be like a godlike scenario. We don't know yet, but we are fortunately still in A&I phase, and it's doing wonders for us already. Can anybody tell me the real-life examples of artificial intelligence that you have seen before, or you may have experienced before? Complex thought operations. How is it artificial intelligence? Is the surgeon involved or not? Robotics. The use of robotics along with the, okay. Yeah, that's one example, but there are much bigger mass consumer applications that you have already used. You just need to get that out of your thought process. Okay, so I'll go into the applications. When you see the applications, you will know that they are actually AI apps. So today's agenda, I'm going to go quickly about my background, which Praveen has already covered. So what I'm going to do is, rather than repeat what Praveen said, I'm going to just give you a few anecdotes that Praveen has specifically asked me to tell you a few stories so that you can see kind of your future, like, you can understand what we learned after leaving OU College of Engineering. And then I'm going to give you AI applications as we just discussed, so that you will see, this is AI, okay. And then I'm going to give you a technical foundation. I'm going to keep it very high level intentionally, a couple of reasons, because I am actually not from the source background. I do have good technical understanding, but I'm not from the machine learning specialization. But that is one reason, but the bigger reason is time. I want to make sure that give the technical foundation just enough so that you understand the kind of the career opportunities you have available in this field. And also, if you are interested in starting your own business, what kind of steps, phases that you need to go through, and what kind of resources you will be needing, both human, hardware, software, whatnot. And then finally, I'm going to give you a very quick overview of the product development and deployment life cycle of the artificial intelligence machine learning based solutions, so that you will know from that where you fit from your career perspective. That's pretty much it. So let me just quickly go through the background. Anyway, we have talked about all this. So there are few things that I've learned, few things at OU as well as after OU. One of the big things I learned while at OU was a comment made by one of our lecturers, a civil engineering lecturer in second year, first term. I remember it so well. Yes, when I say that, you might remember. One day he walked in and he asked us one question. He asked us, what is the difference between a mathematician and an engineer? Can anybody tell me? This I learned at this in electrical engineering building. No, in the main building, because we don't have a proper building. Yeah. Anybody just take a wild guess or whatever you think. The difference between a mathematician and an engineer.
Mathematician is a tool for engineering.
Good. He gave us another. It's true. It's true. Mathematics is one of the foundational tools of engineering. He gave us this example. He told us that if you give an orange to a mathematician, he will look at it, he will tell you the circumference of the orange, the area of the orange, the radius, the diameter, etc. If you give the same orange to an engineer, he will peel it and he will eat it. So the difference between an engineer and a mathematician is engineering is an application field. So my dear friends, focus on applications. Okay? Whenever you are learning theory, ask yourself what is the application of this theory. That's why I asked you the question, have you experienced an artificial engineering application? Whatever you are doing, ask yourself, how does it apply in real life? What am I going to do with this? And whenever you see an application, what is the theoretical foundation of it? Without application, there is no engineering. Theory is very important. Mathematicians and physicists are very important. Without mathematicians and without physicists, engineers are not there. But without engineering, there is no Baba, there is nothing here. So engineering is the field of applications. Focus on it. Eat your orange before you describe it. And the other thing that I learned was, of course, BHL R&D. When I joined BHL Corporate R&D, I was blown away. We went through a lot of training. I was blown away by the BHL infrastructure. I didn't know that BHL was that big. They took us everywhere, to Trichy plant, to Tamil Nadu, to Bangalore, to Delhi. So many BHL plants. I did not know that BHL was that good and that great. Another thing that I learned, I wish I had known BHL before I joined BHL. Another thing, take time, go to these good public sectors as well as private sectors. If needed, take alumni help. Like you want to visit GE, see if Kanan can arrange something for you. If you see it, it's different. When you actually see these big corporations, it's different. It hits you like anything. There is world outside the classroom. Visit as much as possible. Go after your HOD. Go after your faculty. Pester them till they take you to the public sectors, the big corporates. Go after your alumni. If you are there, just ask us. We'll take you. We'll take you to the corporate houses. Go to Google. Go to Facebook. Go to Microsoft. See their campuses. Talk to them. Don't be scared. They are not smarter than you. They are also the graduates of this. Just ask them. The gentleman here in black shirt, he's not scared to ask questions. Ask questions. There's no stupid question. Only stupid question that is the question that was never asked. Okay? So go ahead. Go see the world. Okay, the other thing that I learned after I moved to the USA was I did my master's from Rensselaer. Rensselaer is one of the top 5 engineering colleges, especially for electrical engineering in the US. You know why? If you were ever bothered by Resnick and Halliday physics books, you will know Rensselaer because they are professors from RPI. If you ever bothered by Alan Greenwood's transmission lines books, you will know because Alan Greenwood is the professor from RPI. It's currently known as Rensselaer. You know why Rensselaer is also famous for? Because it's stone's throw from GE Corporate R&D. When I joined RPI, I got internship at GE Corporate R&D in Muscatine, New York. And GE has sponsored my master's thesis. That is the kind of the handshake between industry and engineering college. We have BHL Corporate R&D here. I don't know how many theses are sponsored by BHL Corporate R&D. Come on guys, go ask BHL. It's public sector. They should sponsor you. Have handshake with the industry while you are here. It's your right. Go ask. That's another thing that I learned. GE has sponsored my master's thesis. They paid for it. They gave me the data. They gave me access to their corporate world. I've learned a lot. Ask for it. Just go ask. And the other thing that I've learned was nuance communications. When I joined Nuance Communications, by the way, Nuance is the commercial spin-off of SRI International. SRI stands for Stanford Research Institute. There's nothing to do with Stanford University, it has the same name. But it is physically very close to Stanford University. Stanford is in Palo Alto, California. SRI International is in Mountain View, California, which is right next town. The beauty of SRI is it's primarily funded by DARPA projects. DARPA stands for Defense Advanced Research Project Agency. It's similar to DRDO of India. Okay? Whereas SRI does commercial spin-off of its research. I have never heard of DRDO doing it. Someone ask Modi or whoever you need to ask. DRDO. Come on guys, come out with the commercial spin-offs. You are doing so much research. There's a lot of research goes on in DRDO. My uncle worked for DRDO. He's a very smart guy, but I have never seen him talking about the commercial applications of their research. I know defense is a core secret, so is US defense. But they do commercially spin off some of their technology, and that is the fruits of the technology that we are now using. So ask why, Indian research institutes have to go out and do commercial spin-offs. There's another thing that I learned in the US. Another thing that I learned was nuanced communications. When I joined, I was employee number 30. It was a startup. I was the first woman engineer. I was the first non-white. I was the first non-American to be employed by nuanced communications. I've seen nuance from the OU College of Engineering has a brand recognition in the US. RPI, most of the toppers from chemical engineering every year go to RPI. They know OU very well. Be proud of yourself. OU College of Engineering, they know in the US, it has brand recognition. We just have to market ourselves better in this country. By the way, nuance. So, it is one of the most successful startups in the US history in artificial intelligence. So when I joined in 1996, the first commercial deployment of artificial intelligence happened, which was the Charles Schwab Staff Course system, natural language speech recognition based system. And then we went through the whole series of round A, round B, round C, financing, etc., and went through the upheavals of creating platforms, creating new technologies, creating tools, coming up with new partnerships, marketing, sales, everything, because we were the early employees. I've seen the product development life cycle. I've seen the startup life cycle. Fortunately, I've seen the successful startup life cycle. There are many ways to fail. There are very few ways to succeed. And fortunately, I've seen the successful, and that was just luck. Because nuance also had equal chance of failing. Another thing that I learned is how startups succeed. If you have any questions, you can ask me after that also. Startups. So, Axon Corporation. Fortunately, I had an opportunity to work for Axon Corporation after I did my MBA. Axon Corporation is the largest data analytics firm in the world. So, if you ever wondered that you book a tour and you call SBI or some credit card and they ask you, can we offer you some credit loan offer with some discount on interest rate for your travel trip, and you're like, what the heck, how do you know? How do you know that I'm traveling? It's like these marketers know in and out of us. That's thanks to companies like Axon Corporation. The kind of amount of the data they collect on daily basis about everyone in the US, if anybody ever forgets their address or phone number, their name, they can go to Axon and ask. They will tell you more about you than you ever know. So that's Axon Corporation. So with this combination, I've learned a lot from Nuance and Axon Corporation, which fortunately happen to be the hot fields today. Artificial intelligence and data analytics. But I was mostly into the front-end human-machine interface, as well as I was in the marketing and general management. But I do have enough technical knowledge to cover today. iPhone Siri, have you ever used it? Have you heard of Brad and Naturally Speaking? Indian Supreme Court, Indian High Courts know about it because it's used in transcription. Indian medical transcription companies also know about it because they use this system to transcribe doctors' recorded versions, and they use this system in courts in India to transcribe the court proceedings. Google Voice. Do you know what it is? Google Translate. Have you tried it? Have you tried speech to text to text to speech? Google Translate. Try that if you haven't. You not only type, you can actually talk to it. I think it has Hindi, but I don't know. I don't think it has any regional languages. Amazon Echo, you may have not tried because it is yet to be launched in India. Microsoft Cortana, if you have the latest version of Microsoft OS 10, you will have Cortana on your computer. Sideball and second year other applications. Google's and Facebook image recognition you may have heard of. Like Facebook, the annoying thing, it also can I tag you as this other guy? That's Facebook image recognition. Sometimes it gets it right, sometimes it doesn't, but it's Facebook image recognition. And Zillow estimate. I don't know. I'm not sure whether is there an equivalent application in India for Zillow? The real estate? Not it, right? No, there is one for you. You can start.
Housing.
Is that predictive? Can it predict the house price or guesstimate?
No, I don't think that's
Okay.
they have the data.
They have, data is a big problem in India, but we can collect here. Okay. So this is another thing, Zillow's estimate. What it does is, if you give the address of any house in the US, it gives you the guesstimate. It guesses, like within a certain range, what the price is going to be of that house. And you may have experienced Amazon's product recommendations, like you buy something and it also says, oh, this is another recommended product for you. What do they all have in common? I'm sorry?
Interaction with the customer.
Yeah, they have interaction with customers, that's true. What are they based on? The foundational technology?
Fast data.
Yes, they have fast data. Yes. They are based on fast data. They are artificial intelligence and machine learning applications. They're all of them. Yes, they are based on fast data. Let me just quickly try to demo Siri.
Don't get my voice from you. I don't have a gender. The high temperature is 84 degrees.
Who is the Prime Minister of India?
Checking.
Yeah. Still checking. I mean, you better know Indian stuff. It will come out. It will come out. I think the Wi-Fi. Anyway, yeah. This is Google Voice. Who is the Prime Minister of India?
Narendra Modi is the Prime Minister of India.
Who is the Prime Minister of UK?
Prime Minister of the United Kingdom.
So speech recognition. Siri, iPhone Siri, the technology behind iPhone Siri is provided by Nuance Communications, the company that I worked for. Nuance also owns Dragon Naturally Speaking, which is what we call speaker-dependent model. Google Voice was developed by Google within Google, but it was headed by my Nuance's manager, Mike Cohen. So Mike and I worked together on natural language dialogue analysis for the human-machine interface, which resulted in a US patent for us. After that, he left Nuance, joined Google, he headed the speech recognition department there. So actually, there's a lot of similarities you will see between Google and Nuance. But now Google uses neural networks. So Zillow's estimate is, okay, Zillow's estimate, the way I've told you about it, it's a house price predictor. Okay. I don't know how many of you actually tried Siri settings. We actually get a lot of complaints that Siri is not recognizing properly. Or Siri is not pronouncing certain names properly. You know, sometimes it says Modi, Modai and all that. What you need to do is go into settings and you change the language. It depends where you bought iPhone. If you buy iPhone in US, it defaults to English United States. If you buy it in India, it defaults to English India. If it buys the UK, etc. And Siri's voice also by default is set to something. Sorry? Yes. Models will change. That's the technical answer. Yes, that's right. Models change. What happens is it's not just very simple setting like change the color from grey to blue. What it does is it loads the appropriate model, the machine model that is appropriate to what you are choosing. For example, if I switch from English United States to English India, it loads a model called ENIN. Basically means it's trained for Indian accents. So if you're more of Indian accent, it is better switch to English India, then it works better for you. But although from research we have seen that Indian accents, English US also works fine, because Indian English model was based on English US model. And Siri voice is what she speaks back to you. You can switch from male to female, you can set it to others also. In India, we have released a lot of models, but Siri, I think, is only giving 1 or 2 models because they have not licensed so many from Nuance. So they have licensed very few. So you create models based on some data, and then it's very important that you use the right model for the end user population. So in many artificial intelligence applications, you should give some kind of ability to your developers or the front-end designers to be able to switch this model. Okay, what is the difference between programming versus machine learning? Computer science. Here.
In programming, we are telling the machine what to do, when to do. In machine learning, we are teaching to think what to do, when to do. It means we are not predicting the we are giving the knowledge to predict the situation and react accordingly. But in programming, we are telling what to react, when to react. In machine learning, by doing machine learning, the machine will predict and it will react accordingly.
Yes, that's pretty much good. Programming is instructional based. You are literally giving one instruction at a time, and it's like a dumb machine, it does it. Whereas machine learning is experience based. We're trying to simulate the experience by giving it a lot of data and then asking it to learn from the data, so that when you give it a new scenario, based on the experience from the data it learned, it will predict or it will recognize what you are trying to do. I'm going to give you a very simple example. I'm going to simplify the machine learning here. It's not that simple, but the conceptually is similar. For example, you're a real estate agent, and you're a builder. You're building an apartment complex. You're building an apartment complex, and all apartments have very standard structure. Naturally, the whole complex is in one particular area. Then you can go with programming-based type of scenario for setting the price. You can just have a formula there that says, like, if it's 1,000 square feet for each, for each square feet I will charge 2,000 rupees, and for each bedroom I'll charge an extra 1 lakh rupees, and I will keep a base minimum cost of just the structure as 5 lakhs. So you can just give it and write a simple application that just gives you the calculation. This apartment has 1,000 square feet, 2 bedrooms. Okay, that will be like some 27 lakhs. It will calculate. It's a very simple mathematical formula, as you can see there. Suppose you're a real estate agent, and a lot of houses are coming for sale in Hyderabad. And these guys, they go into a Jubilee Hills in this area, and they see like a 3,000 square feet, 3 bedroom, and they say, this will be 4 crores, nothing less. You take them to Indira Park, similar house, and they're like, okay, fine, 1 crore. You take them to Vijayanagar, and like, okay, 1.5 crores, whatever, right? And then you take them inside and like, oh, no, I changed my mind now, it will be around 2 crores. So these real estate agents seem to know something, and that's what we depend on, basically. How do you set your price, right? You basically depend on the knowledge of the real estate agents. So how do they know so much? It's because they have been in the industry for years and years, and they have gathered the data in their mind. They literally know the variables to look for. They know that area matters, they know that square feet matters, they know bedrooms matter, they know year of construction matters, they know whether it is close to metro or not. So many other features. Based on that, they give you the guesstimate. And then of course it depends on your negotiation power. But at least you should know the range. When you are either buying or selling, you cannot just go blindly buy. You should have a range. And for that range, you are usually dependent on your real estate agents. So the idea here is, of course, we want to mimic what real estate agents do in computers. How do we do it? Okay? I'm going to make you do it now. Very simple mathematics. Don't be scared, just answer, okay? 1,000 square feet house or an apartment, 1 bedroom, listen to it carefully. Car, 11 lakhs. Don't talk me here because I know it's too cheap. 2,000 square feet, 2 bedrooms cost 22 lakhs. How much 3,000 square feet, 3 bedroom will cost? 33 lakhs, right? I never told you per square feet. I never told you per bedroom. How did you figure out? Huh? What did you do? In your mind you did something. You had a pattern, you figured out the variables, you did a very good calculation. You calculated that for each 1,000 square feet it's 10 lakhs, for each bedroom it's 1 lakh. You did that calculation. That is, mathematically speaking, you figured out the coefficients of this, that formula, from the data, from the real data. So what I told you was, I did not tell you the coefficients, I told you the price. I told you the variables, you figured out the coefficients. That is machine learning. It's as simple as it is. Okay. Of course, in real life, you don't have just 2 variables and it's not as simple as it is. You have lot of variables, lot of sales data, lot of variability within the sales data. But nevertheless, using statistical regression models, first degree or second degree or whatever, polynomial equations, you can pretty much do this in computers. You can just do a linear regression algorithm and let the computer figure out this coefficient. In statistics, you put a hat to say that it's an estimate. That's all we do in machine learning. What we do is, we give lot of data. The data, by data I mean we actually give it the sale price, the real sale price that happened. That's what real estate agents know in their mind. They know that in Jubilee Hills, road number 36, last month this house sold for 4 crores. In Vidyanagar, yesterday this house sold for 1 crore. They know that. That's how they predict. Why can't we just state that and let the machine do it? That's what we do. That's machine learning. So now the question is, how good are we? How do we know that model that we built is right? The estimates that we just did are right. There's something wrong with it's not really wrong, but something not good enough with what we just did. What is it? I gave you 2 data points and asked you, and you gave me the 3rd data point. In real life, that's not that easy. What else should happen in real life? What do you need in real life? Yeah, definitely you need more data. And what else you need? Absolutely. You need more variables. Because real estate agents just don't depend on square feet and bedrooms. They depend on a lot. So, what happens is, this is how models can go wrong. This is where, the Facebook does those annoying mistakes. It tags you as somebody else. It doesn't have enough data about your picture. It has enough data to know that you are a human and you are not something else. Like you are not a car, but it doesn't have enough pictures of you. So that means you not only should have more data, you should have the right data. So the more and more data you give it to it, the more and more variables that are realistic. Don't try to overfit to the outliers. In statistics what an outlier is, right? In Jubilee Hills, every house sells for 5 crores and suddenly one house sells for 1 crore or one house sells for 30 crores. That's an outlier. Don't fit your model for that. But you sometimes don't know that it's an outlier. So models at best give you the estimates. They don't give you the right answer. They're giving you the best estimate. So models always have errors. Always. No matter how good a model is, it will always have an error. So the best thing to do before you release the model to your consumers is to estimate the error. How do you do? How do you know? How can you estimate what is the predicted error of this model? Do you see, in politics, when the general elections happen, they say that Modi has, BJP is going to win 200 plus seats and sampling estimation error is plus or minus 3 percentage points. They even know that. How do they know that? How do you evaluate a model? Go ahead. Response of what? Yes, in survey only you have responses, but they are also estimating the error itself. Error can be 20%, they can be widely off. Even the Zillow's estimate, it can be widely off. How do you estimate? You need something to estimate your error.
Actual value.
Yes, you are using action value for training data. You need something. You need test data. You need to test your model. So what we do, where do you get the test data from? You know where to get the training data from. You collect it from for example, in the real estate examples, you go to your sub-registrar office, if you believe them, you take the data, you collect it, you create the model. Where do you get the test data from? Yes, it is same. Yes, so what you do is, when you collect the training data, you keep 80% of it is as training data, 20% of it is test data, so that you are preserving the randomness of the sample. What we do is, for example, you have collected, say, in Vidyanagar area, 100 houses, okay? And you have collected their variables or nothing. 20 houses you use for training the model, 20 houses you set aside, you make sure that you do it random. You don't need to pick, there are enough random algorithms, Python can do it for you. You just, once the model is there, if model comes up with this equation, you just, now don't give it the price. For the remaining 20 houses, don't give it the price. Give it the square feet area and the bedrooms, and it will tell you the estimated price, and you see how much it is varying from the real price. So sum of residual errors is what you do in statistics. Don't bother knowing it, you can easily take statistics course, it's not a big deal. Sum of residual errors is what you are trying to minimize. So if your estimation error is too much, say like 10%, 15%, what you do is you retrain your model. You get more data, you get more features, you talk to real estate agents, what am I going wrong here? You improve on it and then you fix the problem. But you always have that 80-20 split for training and test data. Is avoid overfitting the data, the model to your training data. What do I mean by that is when you create a model, it works very well for your training data. That means you randomly pick any data point in your training data, it estimates very well within certain percentages of error. You give it some other thing, another data point, it fails absolutely outside of training. That happens when you try to overfit. For example, let's see this estimation. This is underfit. So it's missing that point. And this is overfit. Suppose I have another house somewhere here, it will tell me that this is the estimate, which can be totally way off. Because this model is trying to be good itself, it's proving itself that I'm so good, that I'm good for this training data, which is wrong, come on, because you can't have the entire house sales information of entire Hyderabad. You can't have it. You have to take a sample and you have to create your model. So don't overfit it. When you are going to this kind of, this is the fourth degree polynomial equation. If you go to that level of complexity, you will overfit it works in your lab, it fails in real life. You underfit, again the errors. These are the two big causes of error. That means if you have too small of a sample size, or you have variables, too few variables, either underfit or overfit happens, and your estimation is way off. So there is a somewhere sweet spot where it's just about right. You are still off, but not too off. That's the thing with machine learning. Machine learning never tells you that this is it. Even if you show it a dog, it tells you that I'm 90% confident that it's dog, it could be 10% cat. Okay. So what I was talking about is the prediction models is called supervised learning. For supervised learning, what we are doing is we are actually in the training data, we are labeling the data, we are actually giving it the price. So another very famous example of supervised learning is classification. In addition to prediction, what we do in supervised learning, artificial intelligence example, machine learning example is classification, which is very famously used in natural language speech recognition and also in image processing, etc. When you hear an audio, you are trying to classify which phoneme it is. So I'm just quickly giving how natural language speech recognition models are built. What you do is when you articulate something, it actually depends on your human physiology. That's why voices vary from one person to another. So that's why voice biometrics. You know, you have seen the James Bond movie, I'm born James Bond, and it opens the door. It actually happens in nuance headquarters. I used to say I'm Vijaya Kurada and the door used to open. It's used in voice biometrics as well because when you articulate something, the audio signal is very sensitive to your physiology. So we extract the right features, we create a model for you. And then we compare it against a generic model and then we'll check whether you are who you are as you claim to be, and then we'll allow. So voice biometrics work like that. So another thing that is natural language speech recognition is when you talk to the system, the way I've talked to Siri, you need some way to tell the model, like, basically what we do is we build a model of English language, for example. Telugu also is there in India. We have released Telugu model also. It works reasonably well, and we have used lot of Telugu songs data to train it. Because that was easy for us to collect the training. We have collected data, we have paid collected data, but a lot of songs data, but we had a lot of trouble. That's a totally different story. So coming to the language models, the way it happens is acoustic models. Whenever you say something, the audio signal, digitally it looks like this. If you have done your digital signal processing course, you know. When you digitize it, your amplitude and your frequency, everything varies. So you take small samples and then you try to recognize. What exactly are you trying to recognize? You are not trying to recognize words. You are trying to recognize phonemes. Hence, you may have heard of phonetic spelling, like cat, bat, rat, mat, dat, whatnot. So they all end with yat, but just the first syllable changes. Similarly, cat category. You already have your model, you just need to build the models for ergory. So in American English, it's just 48 phonemes, and here American English can be modeled by modeling 48 phonemes. The audio signal match, you can just do with 48 phonemes. Indian English is also not very different, it's some 50 plus phonemes. Hindi, I think we could do with some 60 plus phonemes. Hindi is also not that complex. Hindi is a little bit more complex, but it's not that complex. So you create models for that, and then you sample the signal at you sample the audio signal at like 10 millisecond frame length. Human physiology fortunately is such that you can't speak at such a fast rate that nothing changes. In 10 milliseconds, you can't switch to another phoneme. So that's very good sampling rate, which is very easy. It doesn't even take much storage space or processor power, but it does take a lot of processor power for some other reason. Anyway, we sample, we try to see whether it is whatever. If that were easy, I would not be here. So there's something else going on. The problem with that is just using phonetic model is that there's a lot of confusability, right? Especially the way we pronounce, we do not pronounce like it's just a cat. So there's what is the co-articulation. And we also, the phoneme combination, some of them are illogical. You can never pronounce busy. I don't know what is busy. But if you just model it, it is actually thinks that busy is a logical word. So what we do is we actually superimpose, we create another model called language model, where we throw the legal words. Legal means not the court of law legal. It's just the words that are in the vocabulary, in English vocabulary, that are most commonly used for a given context. we create that model and we use it in conjunction with acoustic model. The first one that I described is an acoustic model. In acoustic model, we take a lot of audio, we literally transcribe it and tag it. By now, you should know what is a tag. You must have done a lot of hashtagging in Twitter. So you tag it to be what is what. This audio, the human transcribers actually listen to it. What they do is they tag the words. We collect a lot of training data, like, we have, say, some Pawan Kalyan dialogue or something, we take, like, sample it and then we tag it, he said something. And then we give it to the model. So it has enough tagged utterances. And then we superimpose language model, so we are constraining so that it doesn't come up with illogical words. On the top of it, we also constrain further to improve accuracy the vocabulary for a given context. For example, for Siri, the vocabulary is not so much medical. You're not, it's just very basic medical questions you may ask. Do I have fever? But you will not ask what is sigma manometer. So that kind of vocabulary there's no need for Siri to know. So for medical transcription, we do have, of course, medical vocabulary we create here, we use it. So depending upon the application, we use another model. So combination of the model, and then we give the acoustic signal. We extract the features that will be taught in the house price, the required features. We give it to the model, and the model will come up with a recognition result, which is its best guesstimate. This is an example of what is the possible word at the end. Another example of machine learning is called unsupervised. All this time I have been giving you examples of if you know the price already, if you know what the user said already and you are transcribing and you are giving it the data, basically you are labeling that this is what it is. Suppose there are scenarios where you know that there are natural classes in the data, but you are not sure how to classify it. So in that case, you will use clustering. This is another one of the very famous examples of machine learning. Like for example, it's used in biological species, it's used in image processing, etc. I'll just give you a very simple example. It's not a very realistic example, but I'll just give you. Suppose there's a lot of image data. Like, that may have like all kinds of images, like Google, the way Google faces. There's too much of image data on the internet. So you want to make the machine somehow classify them as separate, like at least the basic classification, like humans all in one group. Let it not call it humans, but at least let them group into humans as humans, monkeys as monkeys, donkeys as donkeys, cars as cars. Let it first classify it, but not name it. It will just let it dump them into separate classes. Then human transcribers can go, and that's very easy for them. If they see non-human in human data, they'll just say it's non-human, it's an error, I will take it out. So it will reduce a lot of human work. And it will also allow the machine to learn the features for each class. In that case, is what cluster seeking algorithms are used. In a very simplistic way, for example, you have, say, a lot of images, right? Let's say you have a lot of images of vehicles. So the machine will, and then you will give some variables like the number of wheels, the size of the vehicle, the number of people it can carry. You just tell the variables, you don't label what image is what. You just tell the cluster seeking algorithm that there is data, you use this variable, number of wheels, etc. And then in this image, whatever, you figure out, okay? So it says, alright, it has two wheels and it has, okay, 2 wheels is separate from 3 wheels and separate from 4 wheels, it will separate. And within 2 wheels again you will see, okay, it can carry 1 person versus 2 persons, it will separate. So it will at least give you the basic classification. Later you can label and then use it for supervised learning. So this is another very big example. This is just, and this is also used in cancer research. Both the healthy cells and cancer cells are given to the system and then allow it to cluster it. It will cluster separately and then you can label it. Then you can see why, how it like on what basis it separated them then you figure out, then it is very much used in medical field also, cluster seeking algorithm. So this is the basic foundation of the model. We have already talked about the challenges in building the models. It's very, very important that you have the enough quantity of the data and enough sufficient quality of the data in terms of the features. The right features you have to give. It's not about how many features. Are you giving the right features or not? It's very important. That's where the domain knowledge comes into picture when you're creating the models. Let me just give you an example of real life situation. Something unfortunate happened with Google recently. They have TensorFlow, I think that's what it is, the image processing application is. They put it out and they asked the users to use it and let the image processing application from Google classify it. So what one journalist did was, he was testing. New York Times journalist checking. What he did was, he gave it a few pictures of car, recognized as car. He gave it a picture of bike, it recognized as bike. Gave it a picture of aeroplane, it recognized as aeroplane. Flowers, fine. He gave it a picture of two black people. He tagged them as gorillas. And that's really a big PR disaster for Google. Now we know how it can happen. Okay, we know it's not, Google is not racial. They're not making any racial statements here. It's a pure technical thing. They did not have enough data. They did not have enough data for both classes. Neither for black people nor for gorillas, right? That's when the confusion happens. The confusibility of classification is a very big problem. And it's a huge PR disaster. Google being Google, they immediately recovered from it. They tweeted immediately saying, sorry, what they did was, even Google being Google, they could not solve it. But they did a workaround. They removed the label of gorillas from their classification algorithm. So even if you give real gorilla, it won't tell you it's gorilla now. Okay, that's okay. They recovered from the PR disaster, but they had to figure out, fix their problem of modeling because it takes a lot of time. That's how challenging modeling is. Because you know now, you have to have enormous amount of gorilla data, you have to have enormous amount of black data and label it, ensure that your estimation error is close to zero, especially in the US where racial issues are there. So Google, I think for a while we don't see gorilla labeling anytime soon. Another thing about semantic modeling, another example. Let me ask you a very quick English question, grammar. This trophy doesn't fit in this suitcase. It's too big. Listen to this carefully. This trophy doesn't fit in this suitcase. It's too big. What is too big? Trophy is too big. But as per the English, when you have two nouns, when you say it in the next sentence, it refers to the second noun. Ram and Lakshman are fighting. Lakshman fainted. Who fainted? Lakshman, right? As per English, it's the second noun. The it refers to the second noun. But in this case, all of this are trophy. Why don't you say suitcase? Because it's common sense. If trophy, suitcase is too big, why wouldn't it fit the trophy? It's common sense. But machine doesn't have the common sense. It will go with grammar. The semantic interpretation model is failure. It's very difficult. So even with lot of research we have done, we still face, this is one of the last big problems we face. Even in I've done lots of, my focus was on human-machine interface. I've struggled a lot with semantic meaning interpretation, especially in India. Come on guys, Indians are multilingual. I got heart attack when I first deployed the models in India. They don't talk one language. I don't know what they talk, but it's not one language. And they don't finish their sentence. There's a lot of side talk. There is too much of noise. Everything was thrown into it. And another thing that Indians do is the famous head shake. The system asks, you wanted dabang, right? Mean. This is yes, this is no. But what does this mean? And first of all, we don't have the body movement recognition at all. That's another research going on at IBM. Nuance is not doing, but IBM is doing. First of all, headshake doesn't work with natural language speech recognition system. Even if it works, Indian headshake doesn't work. And then they won't say hi, is very difficult to recognize. In natural language speech recognition, you better have some signal. If you have too short signal, it is susceptible to noise in there. And Indians, we were trying to recognize, tell me your account number please, 16-digit ICICI account number. 1, 2, 3. A value product 4, 5, 6. Come on. I cannot recognize what you just said in between. We have faced so many problems that we have to go with, a combination of speech and determined backup, the touch tone backup, which we are also doing in the US, but US is more homogeneous. At least once they say that they are going to speak in Spanish, they stick to it. Once Indians tell us that they are going to speak in English, they hardly stick to it. It can be English, it can be English, but it is never English. So we have to come up with lots of front-end innovation to make very basic things work in India. So it's very challenging. India is a very beautiful country. If you can make things work here, you can make things work anywhere else. Okay. Another thing with machine learning is, as I just told you, the Indian English models, we need a lot, for us to optimize and improve, we need a lot of real-life deployments. Right? Okay, we go to ICICI, we show them the demo, they are like, alright, it works, but we don't know if it works in the real life. Fair enough, right? So we go for pilot and it doesn't work. For all the reasons that I told you. That's a catch-22 situation. For you to improve your model, you need a lot of data from real life. Customer will not let you go to real life unless you improve your model. It's a tough situation. So this is one thing you need to keep in mind when you are working on deployment somehow. That's what Siri did. Remember when Siri was initially deployed, accuracy was very poor, but it was like a toy. So people actually gave it a lot of data unknowingly. Okay. So now that takes us to the most important part of this presentation. If you are interested in careers, or if you are interested in starting your own company in machine learning, what are the phases? So you have a few options, but whatever you do, start with an application. Have an application in mind. What are you going to do? Like, okay, I'm going to do something what Zillow did in the US. Or I'm going to do what Airbnb is doing. I'm going to do what Amazon product recommendations are. Or I will come up with something new, like, the predicting what percentage of electrical engineers are likely to go into electrical engineering after they graduate. Some model. That might help your placement there. So something. Have your application ready in your mind. Then think about what to do with the model. You have two options. You can start from scratch. You collect data, build models, you do the platform integration, or are you going to do it on Android, iPhone, laptops, IVRs, whatnot. That's what also you have to do. Or you have another option. Readily available models are there. From Nuance, from Google, from whatnot. You can choose. You can take readily available models, build a front-end interface on them, and then deploy it in real life as an application, as your own application, or you start from base. So you decide, if you are a startup, decide where you are going to play. Are you going to play this whole game? You are up and against some big companies, but sometimes if you have a niche, you can actually do it. Or you take the licensed models, like for example, Sidepal has licensed models from Nuance. What it does is it creates avatars for you. So, for chatbots, you can insert a chatbot into your website and you can choose the avatar and you can give it which language it should speak to the customer. They are called text-to-speech models. And those models are literally licensed from Nuance. They just give the text and Nuance will pay for them, and that's fine. So they're very quick and up. Sidepal is very quick and up running. And then you have to, of course, pilot and optimize. This is very important for us guys. You cannot just skip it. Whatever you are doing, your innovations, you pilot it to a real life sample, real life people, find your benefits, pilot on them, give them free incentives, pilot on them, and then optimize your model. Then you do the launch, and this whole thing repeats. This whole cycle repeats. You collect data, improve models, launch, find new applications, etc. So as I said, for entrepreneurs, you are either you're doing the entire product life cycle. Basically, the upside is you have more control because it's your data, you can collect, you can improve, it's your algorithm, etc. The downside it is every investment. Data collection is not easy, and data preparation is not easy. You need machine learning specialists. You need to hire them from IIIT because OU is it. I guess, but I think computer science is coming up. I guess, right? Hopefully. But it doesn't matter, I'm pretty sure, because our guys are very smart, you can easily pick up. But anyway, resources heaviness is there, either from data or from the human resource perspective. But getting better this process, because tools like Theory, formerly known as Datto, and MATLAB, etc., or even Google, they are providing the machine learning algorithm tools. So you can just have the basic knowledge of algorithms and you can still build the models. And our licensed technology, which we have talked about, are by our licensed models, bootstrap models. There is a lot of open source projects going on, like Alexa and all that. Even Google has open source, the TensorFlow. Amazon has open source models. You can start from there, you can improve on it. That's an option for entrepreneurs. And careers, and suppose you are not so much interested in starting your own company or interested in careers, what kind of careers are available? If you go back to the product development life cycle, you will see that there is a one-on-one mapping to the careers. Right? You'll see that for each phase you need some resources. So the first thing is data scientist. As we discussed, a lot of data pre-processing has to happen, data collection, data labeling, etc. So you need data scientists, and they usually come with a lot of industry knowledge as well as the statistics background. And machine learning specialists who are good with all those algorithms, like probability search, k-means, nearest neighbors, all those algorithms, HMMs, deep neural networks, etc. In some companies, these two are one and the same. In some companies, they are two different roles. And then you have platform integration specialists who can take these models and integrate with any platform that you are looking at, Android, iPhone, iOS, etc. And then you have application designers. This is a very beautiful skill set to have. Because this is where the crux of it, you are bringing the application to the consumers, the user interface and the user experience designers. This specialization you can do. And then you have application developers, the front-end application developers. Then you have business analysts who can go into a customer site, understand their problem, propose an appropriate solution. That's another skill. For that you don't need to have anything deep, but just enough. So you are jack of all trades, master of none. Go for business analyst positions. A project manager are usually, you don't become a project manager on day one. You join the industry, you show a lot of interest in management if you can survive the whole project phase and resource allocation, the human resource management, etc. Project management is a good step for you. Start looking into that area from the first year of your career. Management is different from any other career, so you need to build yourself. Spend a lot of time with project managers, understand, take project management courses, but project management and general management is mostly hands-on, learned experience. So is product managers. The difference between project manager and product manager is product management is marketing. That means you're bringing out a new product, then product managers own the product and they bring it out live. So you need to have, in addition to project management skills, you need to have the marketing skills to become product manager. And general management. General management you grow within the industry over the time. So in closing, As we discussed, the gorilla example, the trophy example, it's not easy. It's not for paid target. It's multidisciplinary. It's hardly one field. It's a combination of many fields. Statistical and data intensive, yes, but not all roles in the machine learning or artificial intelligence industry need to know statistics. If you're front end, you're not spending that much time. Works in the first try, usually not. You know why? Usually doesn't work that well in the first try. You need to do multiple pilots. Getting better, yes. Front-end design matters absolutely. You have to really focus on the front-end design, whoever is doing it. Resource availability an issue to deal with. Worldwide it's an issue to deal with. It's not just India's problem. Worldwide we have an issue with not only data resource and also the engineers are in short supply in this field. Requires big investment? It depends. It depends what you are trying to do. If you are trying to do the entire product life cycle, it does require big investment. If you are going to start with bootstrap models or if you are going to license others, okay, you have a starting point. Rewarding when it works? Absolutely. So let me close with one of my, the real life experience I had. I think it was in 98-99 time frame when we deployed Delta Airlines application. It was a flight schedule application on IDEA. In contact center, it was actually replacing a human. So we deploy natural language speech recognition system. I have designed the front end for that and I have designed the vocabulary for that. So when it went for pilot deployment, I went to Delta Airlines and we were doing live monitoring of the calls. We were intercepting the calls on a speaker, their marketing specialists and us, we were live listening to the calls as they were coming in. Kind of an old lady, she came in. She called, she talked to the system. The system said, welcome to Delta Airlines flight scheduling system. It actually said system. I've intentionally designed it to say system, to set the expectation. And then it asked questions like, where do you want to go today? From Boston to York. There's no north in the US. But the way I've designed the system is whenever we recognize it as something, we are going to play the city and the state back. Like Hyderabad, Telangana, Visakhapatnam, Andhra Pradesh. Even if the college just says Hyderabad, we were going to play back Hyderabad, Telangana. So similarly, when she said north, the system came back and said Newark, New Jersey. She pronounced it like that. And the caller said yes. Or like, oh, thank God. We didn't recognize, but the system recognized. So it went on. She finished the scheduling, but the actual pricing we were transferring to the agent because that was a pilot deployment. So at the end, it said, okay, thank you for all the information. I'm going to transfer you to an agent. Then she said, thank you, madam. I didn't guess it. I didn't guess that somebody is going to say thank you, madam, to the system. So I treated it as a recognition error. And the system came back and said, sorry, I didn't understand. She was blown away. She understood North. She understood Boston. She understood everything. She didn't understand thank you. What kind of a human is she, right? And she said, I said, thank you. I said, sorry, I still didn't understand. Like, no, madam, I said, thank you. And now it really, the tone has changed. It triggered another recognition error. The tone gets worse, recognition error gets worse. But fortunately, I had to set the limit as 3. 3 consecutive errors, go to the human agent. I said, okay, I'm going to the agent. The agent picks up and she said, you know, something interesting happened. I talked to the sweet lady, she helped me with everything, but she didn't understand thank you. I started laughing and said, you just talked to your computer. She said, oh my God, I talked to the computer. I'm like, yes. You know what? The computer passed the Alan Turing test.
Thank you, ma'am. In the interest of time, again, just wanted to remind that all the faculty members, please assemble in the head search room, EC department. We'll have a separate session with Kanan sir and Vijaya ma'am personally interact. So let's have some questions from the students. Probably just 2 or 3 in the interest of time. We'll ensure that in the next couple of weeks we'll again have a hangout call. Whoever has questions, you can get on a call with both the alumni. Okay, so from the students, any questions, please?
That's my opinion. Yes, and there are a lot of things around it. For example, already computers have started writing news articles. You can't really tell apart whether computer wrote it or human wrote it, and now you know how they do it with machine learning modeling. If you do enough modeling of the news articles, computer will write. They started writing stories. Google has access to millions of books. Google is working on story writing robot, which is a software robot. Is it a threat to human employment? Yes. Is human employment the only way to live? No. That's the problem of macroeconomy. But as machine learning and artificial intelligence engineers, we are very bad. We are going to continue with this. Yes, we do. Especially in the US English, right? They go against grammar, all the known grammar. You know that two positives can never make negative, but in US English it does. Yeah, right, negative. Yes, we have to forcefully model in conversational natural language speech recognition system using that vocabulary model that I was talking. So we would tag it as no, or we would tag it, we will recognize it depending on the context. If it is yes, right, that is yes. Yeah, right. But we can't recognize tone. Tone is not in the model. The research is going on. But it depends on the context of sarcasm. The way we handle it depends. Sometimes we intentionally recognize and reject it. Like, sorry, I didn't understand, although it understands. To avoid setting the expectations to the user that you can understand sarcasm. Might understand this, may not understand that. So we try to keep it to the... It depends on the application. If your application is like a comedy kind of an application, you can model sarcasm. And there were such requests in India from Airtel Value Added Services. They asked us. Last question. Yeah, it depends on the company you're working for. Data, in some companies, they are treated as one only, like data scientists and machine learning. In some companies, what they do is, they don't want their machine learning specialists who are usually the PhDs in computer science, specializing in so many algorithms, to bog themselves down with a lot of pre-processing of the data. A lot of pre-processing has to happen, like noise has to be taken out, the smoothing the data, labeling and all that, they give it to data scientists. But in some companies, they're one and the same.
But they have amazing courses on data science, machine learning, and AI. So definitely do check it out. And IIIT, again, they do tremendous amount of research on. They are one of the best in Asia on NLP and all these different areas. So that's another really good place to check out. So yeah, in the interest of time, one last question. If anyone can have, or we'll just move on. Okay, so people out there. So to just conclude the session further, I would like to invite Mr. Vijay sir.
Pretty interesting and a lot of insights into technology as such. I would like to thank on behalf of the association and the students and everyone for to Mr. Khanna as well as Mrs. Vijaya for delivering a fabulous lecture. But at this point of time, I also thought it would be right to make an announcement which actually was scheduled on the 31st. Okay, because I thought it was the right podium to do the announcement. We talked about benefits, we talked about knowledge trickling, we talked about collaboration, we talked about so many things when I spoke to you guys initially. But most critical and important also is how the alums are helping the institutions, the students directly in terms of contributing to their enhancement of technical skills or getting into research and funding. So at this point of time, I'd like to announce, I'm sorry Vijaya, it's a little surprise. Okay. Vijaya is funding a research project which is basically in the innovation space. And the project was finalized and forwarded to her and with recommendations. One of our students of electrical engineering, Nikhil, is the guy. in the electrical meter space. So I think we might come back to you in due for it. Okay. So I think it's a very, very benevolent thing, and not only Aruna but her batch also is looking at doing a lot of stuff over here, and every batch that comes. So please do respect the alums when they come. There's a lot that they want to give to you guys. Take it with open arms. Okay. So we do understand it's slightly painstaking for us to sit or class or cancel a particular class and sit through these sessions. Maybe we're all typical students like you. We also were sitting on the other side and we always felt bored, but look at it from a different angle. I think there has to be a paradigm shift in the way we look at these whole sessions. Here are people who are coming with open arms to give you something. Please accept them with grace and open arms. There's specifically students, there's a fantastic platform for you guys to move forward. Okay? And I thank the batch of 1991 Electrical, as well as specifically Vijaya, who spearheaded the whole thing and took this or make it happen. Okay? Thank you, Nikhil.
Interact with the smart student.
From the students, and even if any of you have any other innovations that you need support, be it technically, be it monetarily or any other way, definitely reach out to us. We have an innovation committee spearheaded by the eminent guys in the industry. So just reach out to us and we'll figure out how we can help you out. And definitely, just like Vijay ma'am, there are like many other batches who are coming forward to help you out. So definitely use this opportunity. So I would request all the dignitaries to come back to the dais. Let them. So I'd like to request President Sir to give the book.
While we were sitting and engrossed in the lecture of Jaya, quietly walked in our chief patron and the principal of the college. In fact, we have to come and join us, and we welcome Mrs. Fatima, the principal and chief patron of Alumni Association of Engineering College.
Thank you very much.
I'm sure everyone is excited.
As long as it is short, your preparation will be
Yeah, the time is up.
When you say teachers should be short, teachers don't know the meaning of short. My NLP does not recognize short. Speaker of the day, Vijaya Kurara. I have not attended the talk, but I think Mr. Kannan Senior is also here, who addressed the gathering before Vijaya. And then our President, Mr. Ram Mohan, who's an inspiration. He's been sitting all through the talk. So hats off to Vijaya. You made him sit for 1 hour. Our good friend Vijay Kumar, the smiling face of this College of Engineering, and my dear students. This is the first time I guess I'm addressing the students after taking up as the principal of College of Engineering. I'll try to be very short. I think Madam has done such a lovely job, she introduced the subject by asking a few questions and then showing you some slides, giving you an overall picture. And then after, she went into the different techniques, the classification and the clustering topics that she has covered. And then she went on to the applications. And of course, the practical applications were mentioned by her in her talk. I think it was wonderful. So in this short span, I couldn't have done ever so much justice to the subject. But however, I would like to summarize what she said. What she's been saying is basically two things I understand. Correct me if I'm wrong. One is she's trying to extract data, the right kind of data, and then she's trying to build a model around the data. These are two important things that you should take from my thing. I'll tell you one kind of research that went on. One set of students took a froggy, papa, right? To jump. Froggy jump. The frog is to jump. Okay? Whenever they said froggy jump, the froggy was jumping some distance x. Okay? Then they chopped off one leg. They said froggy jump. The frog jumped distance x by 2. Then they cut off both the legs. This time the froggy did not jump. So they concluded, if you cut one leg of the frog, then the hearing power comes down by half. It becomes deaf. Extract the data properly, identify the dependent and the independent variables, okay, and then build an appropriate model to get the right results. Okay? There's so many models sitting there. Okay? And Vijay has been alluding to neural networks or maybe clustering K-means or whatever. Okay? So I think you have so many models around there. Which one suits you best? That is the important thing. Right? So I think the whole course is circled around this idea of what are the models and which one to pick up when you need to. Second thing, she was talking about speech prominently. So she's been applying machine learning to speech, right? But today we are in the era of multimedia. So you have not just speech, you have audio, you have text, you have your database tables, right? Okay. So now you can do this machine learning for anything. So what she said was for speech, but you can still extend the idea for other multimedia data. Now, I being a teacher, the last thing I would do is I would put a quiz. Without that, my lecture will not. How many of you Google 5 times a day? 5 times a day. How many times do you do instant messaging? So what is the data that you're generating when you're doing all this? When you're messaging? It is textual data. It's not the database data. It's not structured. It's unstructured. Okay? So handling structured data versus unstructured data versus speech data. So she even described the different models, you know. She said you have to first have the language model, and in that she had 2 components and all that. So then she described, you know, how to pick up the frequencies and then identify the phonemes and so on and so forth, one part of it. And then the other part she said the language model. So those were the 2 things that she spoke about speech. Now these models may change depending on the media you're operating with. If it's text, the techniques are something. I mean, more or less broadly they're the same, but the steps involved may be slightly different. There are phonemes there in speech. Okay. So for text, what would you have? You have to go back and revise the grammar. Syllables. Right? For text, we have syllables. So this way things change slightly. Okay? That's all that there is to it. So I think this is what I wanted to summarize as to what she said. I think I've done a right summary of what you've done. Okay. So I think with these few words, I should thank the speaker and the alumni who have been so good at this hour, putting together such a big crowd. I couldn't have done. So hats off to them, and thank you very much, the speaker.
End of the day, it's very easy to skip something, but to come down to do to spend that kind of time to educate you guys and help you understand the basic concepts of a lot of these things, it's a wonderful thing. So one big round of applause for our speaker. Making it a grand success. I'd like to thank the President, the General Secretary, and the rest of the board members for helping us put this together, and the student volunteers. And yeah, we'll have the bouquets for the wrong ones. But yeah, so now.
Frankly, I don't blame Pradeep because still he has got the elbow.
Just try. Thank you. So, as the last thing, definitely remembering. Thank you again. So, sitting through the last 3 hours, we have some snacks for you. So please